Hi guys, myself in the principal division Yada following on LeetCode. Delete the middle node of the linked list. So you given head of the linked list, delete the middle node and return the head of the modified linked list. So they are given a linked list of size and you have to delete n by 2 node starting from the index 0. And you could see here, if number of nodes in the linked list is odd, then easily we can delete the node. It's n by 2 value itself. So out of 7, fourth value will get deleted. But when number of linked list is even, you'll be deleting n by 2 plus 1 12. So you could see n by 2 is under 4 by 2, 2 plus 1, 3. Third node you have been deleting. So yeah, what is the approach to solve the problem? So one thing which we can do is we can find the length of the linked list and again traverse till n by 2 node and delete the node. And yeah, so if this is the middle node, then break this pointer over here and point it to this. Again here also, if this is the middle node, then break this and point it over here. But we have other optimal approach. Um, we will be using tortoise method, so which we use for finding middle of the linked list. That will contain two pointers, slow and fast. Okay, I'll write once again. So tortoise method we know the two pointers, slow and fast. So slow will move by one step, while fast will move by two steps. So slow equal to slow dot next, and fast will be equal to fast dot next dot next. And both are pointing to head initially. So this is slow and this is fast. And we will have one more pointer called previous that is pointing to null. So and previous is used to point to slow. We will initialize previous equal to null. So while the loop starts, we will perform these operations and we check how we get the middle node, delete the middle node of the linked list. So initially slow and fast is pointing. So previous will be equal to slow. So previous will be pointing over here. Now move slow equal to slow dot next. This is where previous will help us to keep track of the previous node, previous to slow, and fast equal to fast dot next dot next. So fast will point over here. Again, we can do slow equal to slow dot next. So before doing that, we have to do previous will be equal to slow. Now perform slow equal to slow dot next. Then fast equal to fast dot next dot next. So while coming to the next loop, you could see fast dot next is equal to none. So you can't move further ahead. So you stop over here. So you could see slow is pointing to the middle node, right? And we have the previous pointer as well. If I delete this, these are the pointers which are left. And slow is pointing to the middle of the list. And we have a pointer previous to slow also. So now what we can do, we can just make previous dot next equal to previous slow dot next. Or previous dot next. That is also okay. So previous dot next equal to slow dot next. Slow dot next is this. Previous dot next is this. So this previous dot next will point over here and this will get deleted. Okay. So we'll apply the same method over here also. So initially you have fast and slow and previous will be equal to slow. So next again perform slow equal to slow dot next and fast will be equal to fast dot next dot next. So now you could see fast dot next is none. So you cannot move further again for in the next loop when you come to next loop. So you stop the loop over here. So if the length of the node is odd, then fast dot next will be equal to none. If length of the linked list is even, then fast dot next will be none. So now you stop the loop. Now you have the pointers. Which are the pointers you are having? So previous, slow, and fast. Yeah, we fast dot next is null, but we can move further ahead because there is null over here. We'll move one more iteration. We'll not check for this condition. So if you move one more iteration, so previous will be equal to slow, then slow will be equal to slow dot next, and fast will be equal to fast dot next dot next. That is null. Now fast equal to null. So now you can't move further again. So two conditions. One is fast dot next not equal to null, and fast equal to null. This won't because fast dot next not next can be null. So now you can check the pointers. If I remove this and here as well. So what we have now, so previous is pointing to 2, slow is pointing to the middle of the list, and we have previous one. So break this and point it over here. So how? So again, previous dot next will be equal to slow dot next. I hope you understood the problem. So we have three pointers, previous equal to null initially, and slow and fast are pointing to head. So when you until fast is not equal to null, fast dot next is not equal to null, you do previous equal to slow and slow equal to slow dot next and fast equal to fast dot next. So list node previous equal to null, then list node slow equal to head, and list node fast equal to head. Now my head not head actually fast not equal to null and fast dot next not equal to null. So what do we need to do? If in case we take the condition fast dot text not equal to null, then what happens is previously pointing here and slow will be pointing here. So in that case, what we need to do, we have to do one extra step. We have to check again fast dot next is equal to null. If that is equal to null, then you have to perform previous equal to slow and slow equal to slow dot next. So that will reach again over here. Otherwise, this condition will directly we can take. So while fast is not equal to null, fast dot next is not equal to null. We have to make previous equal to slow and slow equal to slow dot next and fast equal to fast dot next dot next. Yeah. So next make previous dot next will be equal to slow dot next. So what we need to return the head. That is the original linked list. Now you will get the modified linked list. Yeah. We cannot assign next because okay. This condition we need to handle previously. How if head dot next is equal to null. So if there is a single node, they're told there can be minimum of single node and 10 power 5 times. So if there is a single node, head dot text will be equal to null. Then in such case, we have to return null because that will only be the node and we delete that node as a middle node. So yeah, if you understood the problem, please like the video and subscribe to the channel. We'll come up with another one next session. Until then, keep learning. Thank you.